A pneumatic switch is a type of switch that relies on compressed air for its operation. The term pneumatic itself refers to air, confirming the initial understanding. Fundamentally, a pneumatic switch utilizes the force of compressed air to actuate a change in its state, effectively functioning as a control mechanism. The typical construction of a pneumatic switch includes a housing, which encloses the internal components and provides a structure for mounting and connection. A diaphragm or piston is a crucial element, acting as the interface between the compressed air and the switch's mechanical components. When compressed air is introduced, it exerts pressure on the diaphragm or piston, causing it to move. A spring is also commonly incorporated to provide a return force, ensuring that the switch returns to its original state when the air pressure is removed. The compressed air acts against the diaphragm or piston, and this movement is translated into a change of state within the switch. This change of state can be used to open or close an electrical circuit, allowing the pneumatic switch to control other devices or systems. Pneumatic switches find widespread application in industrial settings, where they are frequently employed to regulate the flow of air or other gases. For instance, they might be used in pneumatic cylinders to control the movement of machinery or in pneumatic valves to regulate the flow of fluids. Their robust design and ability to operate in harsh environments make them well suited for these demanding applications. Beyond industrial uses, pneumatic switches are also found in some automotive applications, notably in brake systems. In these systems, the pneumatic switch may be used to detect brake pedal position or to control the application of air brakes. The use of compressed air offers a reliable and responsive means of controlling braking functions. There are several notable advantages associated with the use of pneumatic switches. Firstly, they are generally relatively inexpensive to purchase and maintain compared to other types of switches. This cost-effectiveness makes them an attractive option for many applications. Secondly, pneumatic switches are typically easy to install and operate. Their simple design and straightforward functionality contribute to ease of use. Thirdly, pneumatic switches are known for their durability and ability to withstand harsh conditions. They can tolerate exposure to dust, moisture, and extreme temperatures, making them suitable for demanding environments. Fourthly, pneumatic switches are considered safe to use in hazardous areas. Because they do not rely on electricity to operate, they eliminate the risk of electrical sparks, which could ignite flammable materials. While pneumatic switches offer numerous benefits, they also have some limitations. Firstly, they require a source of compressed air to operate. This necessitates the installation and maintenance of an air compressor and associated piping, which can add to the overall system cost. Secondly, pneumatic switches can be slower to operate compared to other types of switches, such as electronic switches. The time it takes for the air pressure to build up and actuate the switch can introduce a delay in the system's response. Thirdly, pneumatic switches can be noisy when operated. The release of compressed air can generate a hissing sound, which may be undesirable in some environments. In summary, a pneumatic switch is a controlled device that uses compressed air to change states. It is frequently employed in industrial automation, pneumatic systems, and certain automotive functions. Its strengths include affordability, durability, and safety, especially in hazardous environments. The limitations are the requirement for compressed air, potentially slower operation, and the possibility of noise generation. When selecting a switch for a particular application, it is essential to weigh these advantages and disadvantages against the specific requirements of the system.